All right, so now we're going to talk about emulating devices and emulating different connection speeds for users. So we know that the web isn't just accessed on high-speed laptops anymore, right? We access the web on all sorts of devices, on big screens, on small screens, on screens in the middle, tablet devices, on watches. How many have a smartwatch? Got one.
I got a dumb watch.
So yeah, we have all different, actually smartwatches, most of them don't have browsers, though some of them have experimental browsers. But people access the web on all different types of devices. And there are a couple metrics that we might want to simulate there. So there's this icon in Chrome DevTools that's really awesome. Right next to the magnifying glass, you have the phone icon. Clicking that opens up like a whole new world. So if you click that, you get this whole new section over here. And now you're in like emulation mode. So now you can do a whole bunch of things. One, you'll notice this ruler has shown up for pixels. It shows both the width and height pixels. So this can give you a good idea of your device size or your viewport size. And I can actually change my viewport size right there. In the old days, or on another browser, maybe you might have to change the actual browser width to do that. But now you can do it in DevTools directly. You can also adjust the, I think this is adjusting the scale on this ruler. All right, so you can also go to a preset selection of devices. So if you click here on devices, you'll see a whole bunch of kind of preset device types. So I could select something like Apple iPhone 5. And it says you might need to reload the page for proper user agent spoofing. So first what's happening is it resized it. That's cool. I can reload here, and now it's actually going to tell the server that I'm requesting this from that I'm an iPhone. I'm not really an iPhone, I'm still a Chrome. But it's telling it that it is iPhone. And the reason it's doing that, we call that the user agent. The reason, the user agent string, the reason we're changing that user agent string, that identifier, is to, if the server is delivering a different experience from mobile devices based on that user agent string, this will trick the server into giving you the mobile experience. So you can use that to debug, which is very helpful. So this is the size of the iPhone 5. We can rotate by clicking this little rotating button. And that's going to rotate as if I was rotating the phone. I can rotate back. It's going to tell me the pixel ratio here. It'll also fit to my screen if I click check to fit, but it's still the same pixel width. Yeah, I can uncheck this box.
Fit to screen?
So if I uncheck this, you'll notice that now I have to, I actually have to extend my browser if I want to get down to the bottom. So
it's just making the phone fit to the screen.
Yeah, this is scaling down so I can see it on the screen.
I got it.
On my one browser. Yeah, it's not actually changing the pixels though. You can actually see the shadow in the background. This is the actual width of the document. And then I can
refresh. No.
So in this case, it's not actually resizing, which is fine. But you can actually see the size there, right, of what the document is. Oh, the reason is because I changed the zoom. Okay. No, it's still doing that. Okay, cool. So anyhow, why don't I bring up a more interesting website here? We'll go to Twitter. And actually, you can tell here because I've told this, because I've told it it's an iPhone, we can actually see this is the mobile version of Twitter that it's given me. So this isn't like responsive. I mean, it's fluid here, but if I make it bigger here, I'm not actually going to the desktop version. It's not responsive in that sense. So that's interesting. You can also throttle your network speed. This is a fairly new feature, and it's really useful because a lot of times when we're developing on very high-speed internet connections, if we're going to a server at all, or we might be going to a local device anyway. So we can actually throttle that internet shrink to fit, etc. But if we click in here, we get some other information. So we can change our CSS media if we have specified style sheets for different devices. So if I change that to print, it's basically like the browser telling. It's browser telling the site that I want the CSS style sheet for print, not for screen. I can go into network. Again, I have the network throughput. I also have spoof user agent like before. And this is the actual user agent experience. This is what user agent strings look like. They're really kind of big and ugly and kind of hacky. So this is like Mozilla /5.0. You might be thinking like, I'm not on Firefox, right? User agent strings have a really interesting history. They're really like that for historical reasons, because they ended up, user agent strings were a way to identify browsers. And so when a new browser came along, they'd be like, I want you to give me the website like you were giving Firefox. So, you know, give me the Mozilla one. And so the browsers sort of have these very kind of hacky user agent strings, and they're hard to rely on, but we still use them. This last one is the most interesting, I think. The first checkbox is emulate touchscreen. If you notice when I mouse over here, my mouse is no longer a pointer, it's this little gray circle. That means I'm emulating touch. So I actually can click and hold down, and when my mouse pad is working right, it will treat it like touch. So if let's see, I go to Nexus 4, and I reload, I can actually click and drag, and that's touch. So I can emulate touch, and then I have touch events. I can also emulate geolocation coordinates. So if you have a website that responds to where you're located, so you actually tap into the browser's identification of where it is. And a lot of times you need user permission to do this, so it'll come up at the top. Do you want to share your location with Google Maps, for example? Well, maybe you're writing a search engine, say, that returns different results based on where the user is located. And maybe they're on their phone, maybe this is a mobile site. You can emulate.
Go to Google Time, just type in time. Yeah. Yeah, so it says 202, and that's in Fresno.
Oh, yeah.
But then you can drop in for your last long 8.65.
Let's see, Google wants to know my location. Sure, Google can know my location.
8.65 lat and 115 long.
Emulate geo, you have to check the box. 8.65.
And then 115.21.
All right.
See if that does anything different. Just an experiment.
Oh, it's being stubborn.
That's Wally.
It doesn't seem to be. Is it 865? Yeah. Yeah, no, for whatever reason, it doesn't seem to be emulating. Do a hard reload there.
North, south, east, or west?
Yeah, it's
No, it should
8.65
work.
south. And maybe that's what you need, 8.65 south. And 11521 east.
I think here we go. There we go. Well, I thought I was in Indonesia.
Yeah, that's right.
Oh, that's where it is. Okay, cool. Yeah, so so there I just told Google that I'm in a different place. I needed the negative on the first one, that's why. You can also emulate position unavailable. You can even emulate the accelerometer on a phone. So if you're testing devices and you want to emulate that, I don't do any of that, so I can't give you more details there. But point being, a lot of really cool things there. I'm going to also just briefly call out rendering. If you're really, really interested in web performance, you can look at actually rendering performance. And I talked a little bit about how, when you manipulate the DOM, you end up doing relayouts or repainting. You can actually see little rectangles here when things change. And so if I click on the Google API here, you notice those green rectangles showed up, and you'll should see it when it reloads. Oh, I'm on a 2G network, man. That's why it's slow. So now you'll see sort of some green rectangles show up, and as I scroll down, you'll see them as well, where it's repainting, or if it needs to repaint. Yeah, I mean, this is more interesting if you're doing really low-level manipulation, but that's a really low-level optimization. But that will sort of call out paint regions, and you can even pull up your FPS meter. This is actually kind of interesting, so let me take this
What's
away.
FPS?
Frames per second.
Per second.
So your FPS meter will give you frames per second. It will show you how many frames per second you have at a particular time. So as I do things, you'll see that change. These are how many frames are able to be rendered per second. Yeah, again, more interesting on like performance-sensitive applications. It'll tell you things like GPU memory and very, very low-level information, but very useful information if you're doing optimizations. So we'll take that away.
What the heck?
Yeah, a lot of these things you'll never necessarily work with, but it's good to see what it is when you run across it. All right, we'll go to timeline here. If I reload on my browser, so timeline allows me to see what's happening over time in my browser. So timeline will tell me everything from JavaScript execution to network downloads to paint rendering. So to start the timeline, what you want to do is hit the record button, and then I can just reload my page. I could also do something else, but reloading is helpful. So I'll finish the reloading, I'll scroll down a bit, and then I'll stop. And this is what I get. So there's a lot going on here. We'll just step through it a little bit, but there's a lot. So first we have the aggregate time and what happened during that time. So it says the range was 0 to 7.63 seconds. Well, if I only want to see kind of after, say, I reloaded the page, it's probably like right here, I can select a subset here. And I'm not sure why that isn't updating down the bottom there, but we'll just leave that for now. But now I can see a certain subset here, and I can see the different things that are going on. These toggles up top will toggle the different modes here, so I can see the frames view or the flame chart view. But this here is this sort of waterfall that, and I call it a waterfall because it kind of keeps going down like this. This is showing everything that's happening on the page, and if you read it closely, you'll see a whole bunch of things happen over and over again. So we have update layer tree. So that's at purple, which means it's rendering related. Purple is rendering. Then we have an event, a mouse move event. I moved my mouse, and I apparently had something that was listening on mouse move event. And if I click here, I can actually see what JavaScript file had that, and I can click in and bring me to the source file, where we say on mouse move do something. That was a function call, which is why in the timeline it comes up, says a function call, and then it also is orange, which means this was scripted. Select all this again. There we go. The range for some reason wasn't updating, but now it's updating. It's saying 2 seconds to 4.45 seconds, which is a total of 2.45 seconds. So that's that period that I selected. So function calls are this yellow, orange. Loading is any network request. And I have send request. This looks like a whole bunch of images. You have logo.github.svg. You have this blogger PNG. So we have a whole bunch of images here. We also have some JavaScript files, conversion.js, and these are all being downloaded. You notice some of these things can happen in parallel, but some of them are blocking. So the browser has made those decisions based on whether there's an async attribute or how many requests it can make at a particular time.
They're stacked on top of each other. That's happening at the same time.
Exactly, yeah. If they're stacked, they're parallel. If it's
Step
happening,
forward, that's not.
yeah. If they as they move forward, that means they have to wait. Or they might have they didn't have to wait, but they did wait because they happened as a result of something else later on, same event.
So one of the ways you kind of get a view as to what's going on with your page is like right there you have a big chunk, right, where everything had to wait for that big chunk to happen.
So this is HTML parsing. We talked about HTML parsing not happening in parallel normally. Because when it parsed this HTML, it had to do a bunch of things like evaluate script. It had GC event, garbage collection event. So garbage collection event happens when we build up so much memory, and the browser goes, okay, we're going to clean up all these unused objects in memory because they're taking up too much space. So the garbage collection goes through and deletes the objects that it can delete. It only deletes objects that there are no longer references to. If there are references to objects, it can't delete them. So when there are no longer references to them, you can delete them. And that actually takes some scripting time to delete it. The browser has to do that to work.
I've got a little resource I just emailed you. Would you mind checking your email and see if you can bring that up?
Yeah. Here, 1 second. Can we pause for 1 second?
Yep.
And we'll set that up.
Yeah.